Hi, good morning. This is April 11, 2021. Today I'm going to show you another problem that I use IP table trees to sort out the solution or figure out the root cause. So I have this website that I cannot reach. So here is the error. This site can't be reached. And how we troubleshoot this problem using IP table trees. So by the way, this is a website services running in a Kubernetes pod. And so how we can, again, use IP table trees to trace the packet that travel through the Kubernetes pod and the underlying Linux net filter system. Okay, so here is the Linux box that runs the Kubernetes cluster and also has the pod for this website. And I already turned on the IP table tracing. So let's, the IP address is 10.3.72.13. And so I'm going to use the destination as the IP address. And the destination port is 443. So because there are a lot of IP table tracing log, I want to filter out the destination IP and the destination port when I reload the web page. Okay. And so I'm going to click the reload button. Okay, so the page still unreachable. And here we got some trace log. So, and so there are quite a few trace log because it's traversed through the IP table chains. So in this video, I'm going to show you how we can use the, since this is a TCP packet, if we look at the packet ID, for example, the packet ID shows as 0. That's the IP header packet ID. So we cannot use this as identifier, packet identifier. So what else we can use to use as a unique packet identifier to trace the specific packet that travels through the net filter system? We could use source IP or source port or destination port, but since the packet may travel through the net filter system, the net filter may do destination IP, destination port translation, or source port or source IP translation. So we cannot use that as an identifier because it could change. So what else it will not change? So for TCP, we can actually use the sequence number as a unique identifier. Because for TCP, say like a three-way handshake, like a TCP SYN packet, the SYN packet sequence number will not change when it travels through the letter filter system. Because the letter filter basically only do the layer 4 TCP port translation, it will not change the TCP sequence number. We can use this to filter out the whole packet. Okay, so we can use this identifier. Actually, this is a TCP SYN sequence number, and then we can also give a ACK 0. That's the TCP three-way handshake, the first packet, the SYN packet. Okay, we can use this as a filter to extract out the whole packet. So let's pipe it to a log. So I wanted to like pipe out the log file to a temporary log file, so I can use the all the filter trick to find out the packet we want. So we use the grep to search this packet. And let's pipe to a, say, sequence number, this, okay, to another file. Oh, I didn't give the input file. Okay, so it's done. Let's look at it, see if we have something there. Okay, we got some stuff here for the whole packet. And so for us to easy to look at it, let's use an egrep filter to counter the packet. So this is in my previous video, I use this filter. I have this in my video comment to use this filter to highlight the packet when it travels through the let filter. And okay, so we want look at this file. So as you notice, in the egrep, I just basically search all the tables, the letter filter tables, the raw table, the lat table, and after that, it's this is the raw table, then the chains, and the lat table, and the chains, letter filter chain, okay, filter table. So I just like want to highlight the packet when it travels through the tables and the chains for us to easily to look at. Okay, so I also highlighted the destination IP and destination port. So here again, so this is the last packet for the tracing, for the trace. So if we look at the last packet, it's in the Mango table post routing. Okay, so the destination port changed from port 443 to port 9443. So there is a destination port translation. And then also notice that destination port, destination IP is changed from our .13 IP address to .39 pod IP address. So there is a destination IP address translation. Okay, so let's look at it from the beginning of the packet when it comes to the net filter, and just make sure we have the right packet. So this is the first packet that's got a twist. And again, this is the first packet, the raw table pre-routing. Okay, and we got the source IP is my client IP. The destination port, destination IP is the 13.10.3.72.13. That's the original destination IP. Okay, and yeah, so this is our destination IP, right? Okay, destination IP. First, raw table pre-routing, and destination port, sequence number. Okay, so then the packet follows through the raw tables and the pre-routing chains, and all the way. So raw table, destination IP. Okay, raw table. So this is all raw table pre-routing. Raw table, Mango table, destination IP, still the original one. Okay, Mango table. So yeah, Mango table pre-routing. Yeah, come down, and still the destination is still not changed. NAT table pre-routing. Yeah. Okay, so eventually it will change the destination. Okay, here is the Mango table. Forward chain. The destination IP address is changed here first in the Mango table forward chain. Change it to pod IP address. So so this is a pod running in the Kubernetes cluster. We can tell because usually we use 10.244 as a pod IP CIDR. Okay. And also the destination port is changed to 9443. So let's find out what this pod IP is. 39.9443. Okay. Let's go to our get pod. Right. We will know. So remember, it's the .39. So let's see if we can find the .39 address here. Let's .39. Do we see .39 here? No .39. No. Right? So we looked at all the pod IP. There's no 10 244.0.39. So the pod IP doesn't exist in the Kubernetes system. So that's the problem, right? So we are trying to access this website, and then eventually the net filter translated the destination IP to a pod IP, but the pod IP doesn't exist in the Kubernetes cluster system. So that's the problem, right? We found out the problem, and yeah, I don't want to give the video too long. Maybe we can explain the problem further in the next video. And so use IP table trace. We found out what the problem is. Okay.